And yes, we will be have an exam preparatory for unit 2. Okay, so and I will start with the multiple choice problem first. Okay, so and because we this is almost 2 hours, okay, less than 2 hours, for exam preparatory, so I will go over the multiple choice problem. When we are done, okay, there are some handout problem which are available on your D tool. Okay, we will try to go over those problems as well. Okay, as I said, like the first example party, I will record this session just in case if you are interested, you can send me an email. Okay, so I will put my email address, okay, here. Okay, so you can send me an email. I will send you the link of the recorded session by email to you. Okay, so sorry. So this is gonna be Gurbana at star.lcc.edu. Okay, this is my email address. Gorbana at star.lcc.edu. Okay, we start with the first question. Okay, so please, if you have any question or concern, okay, so you can just turn on your speaker, okay, microphone, okay, and you can just ask any question that you would like, okay, or you can, I will just keep tracking the chat box. So, and you can even ask your question in the chat box, okay? So I will be keep tracking the chat box anytime. So we start with question number 1. So I have the formula sheet, okay, in the right side. So I go back and forth, okay, if we need a formula sheet, okay. So question number 1, the question number 1 is telling that the difference between impulse and impact force involved. So, I look at the formula sheet. Yes. Okay. So the first thing that I see, the first one is rho equal mass time volume. Okay. Is the volume density mass time volume. The second thing is impulse. Okay. I just thought it is just talking about the impulse. Yes. Good. Impulse and impact force. There you go. Impulse is the force time delta t, and force time delta t is change of mass time velocity. Okay, change of mass time velocity is momentum. Good. So I think this should be a momentum. Okay, it's P equal mass time velocity. Good. It's the momentum, it is a P, not rho. And so it's telling that impulse is equal change of momentum. Okay, so you can rewrite this equation. Force multiplied by t, we call it impulse. By having this, okay, we can calculate the change of momentum. P is the momentum. Okay, so in this formula, what do you see? Okay, the difference between impulse and impact force involved the distance the force act, mass and its effects on resisting a change in momentum, the difference between acceleration and velocity, time the force act.
We're talking about momentum, so the mass and its effect on this can change from that.
Okay, which one do you select?
No, that's not gonna work.
The second one, mass and its effect on resisting a change in momentum. Resisting change in a momentum, okay, we don't have, resisting a change, okay, on a momentum. We exert force, the momentum will change. Okay, the momentum will not resist, okay, so you exert force on object, okay, let's say that you have object is stationary, you exert force. What happened? I exert a force in a short amount of time, okay, and it start moving. It means that the momentum of that particle change. Good. But how much force? If I just keep pushing this is gonna move for ever. Okay, it will accelerate. Good. But if I just exert for a short time, okay, so you're changing the momentum. Is it start to move and it stop? Good. It was at rest, start to move. Okay, the force which is exerted on a specific time. Yes. Okay. The right answer is the last one. Good. Question number 2. Two objects have same size and shape, but one is much heavier than the other. When they are dropped simultaneously from a tower, they reach the ground at the same time, but the heavier one has greater speed, momentum, acceleration, all of the above, none of the above. Because they are reaching to the ground at the same time, it means that there is no air resistance. Yes, okay. The only force that is bringing those, and cause the object to fall down. Okay, so is the force of gravity. Good. So, and we know that the acceleration is going to be the same acceleration. Okay, it's moving with the same acceleration because they are reaching to the ground at the same speed. Okay, the acceleration is same. S speed is same, okay, because the velocity, okay, if you go look at the formula, you see velocity is acceleration multiplied by time. Acceleration is the same, so time is same, okay, the velocity is going to be same. Good. So this is same, okay. How about momentum? What is the momentum? Momentum is mass time velocity. Okay, the velocity was same, yes, or the speed was same, but the mass is same size. Two objects, same size, but one is heavier. Okay, mass time velocity. The heavier one has a bigger momentum. Good. So the only thing that has changed here is not the speed, is not acceleration, it is just momentum. So the momentum is the right answer. Okay. Question number 3. Uh, a bullet is fired from a gun. The speed of the bullet will be about the same as the speed of the recoiling gun. Okay, so if the mass of the bullet equal the mass of the gun, because the velocity is conserved, because the momentum is conserved, because both velocity, okay, and momentum are conserved, none of the above. Which one do you think is the right answer? Those who are home, okay, you can type in the chat. Okay, so bullet is fired from gun. Okay, I'll try to draw the situation. Good. So let's say this is a gun. Okay, so okay, not perfect gun. Okay, assume this is gun, and this is a bullet. Yes. When the bullet was inside the gun, okay, it's not fired yet. Okay, the system momentum was 0. Yes. Good. Before firing. Now it's fired. Okay, so now it's fired. When it's fired, okay, so what happened? The bullets go forward, okay, and then the gun it will be go backward. Yes, okay. Why this happened? Because of action and reaction. The bullet, the gun exert force on the bullet exerts force on the gun. Okay, so let me just change the color. Same force, same force. You remember we said that the impulse is changes of momentum. So when we are telling that impulse is changes of momentum, okay, these forces they are canceling each other. Yes, the system has two forces, one force right, one force left. Okay, they are canceling each other. It means that changes of momentum is 0. It means that the momentum before should be equal momentum after. Good. Momentum has not changed. Okay, the momentum should be equal each other. When the gun is not fired, what is the momentum? Initial momentum is 0. Yes. When the bullet is fired, the gun goes. Is gonna be the mass of the bullet. I just put n this, okay, index of b. Okay, it means that the mass of the bullet and the velocity of the bullet. Yes. This is mass of the gun, yes, and the velocity of, sorry, gone, okay, and then the velocity of gone. Okay, good. I use the velocity, okay. The Vg is the velocity of gun, mg is the mass of the gun, mb is the mass of the bullet, okay, vb is the mass of the gun, okay. So what is the momentum of the system when it's fired? I have bullet, and bullet is going to the right, yes? It's going to be positive mb time velocity of the bullet, yes? What else I have? I have gun. Okay. The gun is moving backward. It means that mass of the gun, yes, but negative velocity of the gun. Good. So we said that momentum before should be momentum after. Good. So PI should be equal PF. Okay. So what is the PI? 0. What is the PF? Mass of the bullet time velocity of the bullet. Yes. And positive negative is going to be negative. Yes, okay, it's going to be, because there is a positive here, there is a negative here. Negative positive is going to be negative, it's going to be mass of the gun and velocity of gun. So if I rewrite this, it's going to be mass of the bullet, velocity of the bullet. Okay, I'll take this negative to the other side. It's going to be mass of the gun time velocity of the gun. Yes. Okay, what the question was asking, a bullet is fired from a gun. The speed of the bullet will be about the speed of the bullet, yes, will be about the same of the speed of gun. These two are same. When they are same, what happened? They cancel each other, yes? When they cancel each other, what is left? Mass of bullet should be equal mass of the gun, yes? If this happen, if the bullet, the gun is moving at the same speed of the bullet, okay, but the opposite direction, their masses have to be same. In reality, this doesn't happen, okay? Because the bullet goes faster than gun, okay? Why? Because the mass of the bullet is bigger than the mass of the gun. That's why the velocity of the bullet is bigger than the velocity of the gun, okay? Because in this situation, it's telling that if this happen, bullet and gun should be the same mass. Okay, what is the right answer? The first. Good. No question at home? Okay. Question number 4. So let me just erase this. So again, which formula I use here? I just derived the formula, but I just wanted to show you which formula. Okay. When we have a collision, okay, we use momentum before equal momentum after. You see that? Okay, this is the formula that I use. MV before equal MV after. Momentum before, momentum after. Okay, that's the formula that I use for this problem. Okay. Question number 4. Okay, recoil is noticeable if we throw a heavy ball while standing on a roller skate. Yes. If instead we go through the motion of the throwing the ball, okay, but hold on it, or net recoil will be same, 0, or small but noticeable. Recoil is noticeable if we throw a heavy ball while standing on a roller skate. Yes, let's say this is a roller skate. Yes, we are standing in a roller skate. Good. And then if we throw the ball, yes, let's say throw the ball move forward. Yes, the entire system move backward. Is not if instead we go through the motion of the throwing the ball. It's telling that if you go in the direction of the ball that is moving, so or net recoil, it should be 0. Yes, okay, so net recoil should be 0. Okay, so if we are moving in that direction. Number 5, the force that accelerates a rocket in outer space is exerted on the rocket by the rocket wings, exhaust gases, and rocket's nose cone, atmospheric pressure, none of this. This is exhaust gases, yes? So that's why, exhaust gases and using the Newton flirt law, action and reaction, okay, so it's pushing the system upward. Number 6, which would be more damaging? Driving into a very massive concrete wall with no give, okay, so it means it doesn't say, okay, so it will be reflected, it will be just stop, yes, but or having a head-on collision, okay, at the same speed with the identical car moving toward you with the same speed. Okay, the car has more damaging, would be more damaging, the wall would be more damaging, okay, so both the same. If you head on the wall will be more damaging, or if you head on the car, or it is impossible to predict. This question doesn't give us a lot of information, okay? It's telling that when it's a massive concrete, okay, you know, what if you hit the wall and you reflect? What if you hit the wall and you stop? Okay, here the momentum becomes zero. Here you have one momentum reaching to the wall, yes? One momentum when it's reflecting back, yes? Okay. So it doesn't tell us. It doesn't say, okay, what happened, okay? And the scenario for these two situations would be different. When the car completely stop would be different than no, the car will reflect it back, okay? When reflected back, there will be less damaging than when it is a stop, okay? Because the entire impulse, okay, will exert on the car, yes? Okay. So number 7. A fan attached to an ice sailcraft stalled on a windless day blows air into the sail that bounces backward upon impact. The boat can then move in the direction of the wind impact force. The boat they then move, but in the opposite direction of the wind impact force. Okay, not moved by any wind. Let's say you have an object is stationary. You just exert very big force in a short time. What happened? The object moved in the direction of the impacted force. Yes? Okay, so what is the right answer
So
then?
the move in the direction of the wind impact.
Yes. Okay. Number 8. A golf ball moving forward with 1 unit momentum strike and bounce backward of a heavy bowling ball that is initially at rest and free to move. Okay, that's really good question. Okay, so I need to just go one by one. There is a golf ball, yes, moving forward with 1 unit momentum. This is a ball, okay, it does have a mass, yes, m. I don't know what is the mass. The momentum is 1 unit, yes, and is moving forward. And a strike and bounce backward of heavy ball, which is a stationary, yes? Heavy ball. Let's say this is a capital ball. Okay. What is the station? When is the stationary? Is zero. Good. The momentum is zero. This is before collision. Before. What happened after? Is telling that the 1 unit of momentum ball, yes, bounce backward. So this one bounce backward. But what is the P? I don't know. What happened to the bowling ball is set to the motion, but it's telling that this big one, yes, will have a new BP. This is where the collision happen, yes? Because when they are exerting force, these forces, they cancel each other. Net force is zero. It means that changes of momentum is zero. Momentum before, we are using again this equation. momentum before, yes, P before, yes, should be equal P after. This is before, this is after, yes? What is the momentum before? 1. What should be momentum after? 1 again, yes? So it means that this P, which is in the right, plus this P, yes, which is in the left, yes, negative P, when you add should be equal to 1, because P before should be P after. After we will have 2 momentum. One for the big ball, yes, the other one for the small one, okay? Okay. So what is telling, okay, how we can calculate the P? P, the capital P, yes, for the big ball should be equal the small p, yes? We can take the small p, okay, to the right, okay? It's going to be positive p. Positive p plus 1. What is the right answer then?
All right. That was,
You know, the capital P, yeah, the momentum of the ball, rolling big ball, yes, is the momentum of the small ball plus 1. It means that it is bigger than 1 unit. Make sense? Okay, because it's P plus 1. Okay, so the right answer will be more than 1 unit. Make sense? Any question at home? Okay, let me erase these. Okay. A sandbag is motionless in outer space, yes? A second sandbag with 3 times mass moving 12 meter per second collide with it. Let me just draw the situation. Okay. This is a sandbag, yes? The mass is m, good? Is a motionless. Velocity is 0, good? A second sandbag, okay, 3 times bigger. If this is m, this is gonna be 3m, yes? Moving how many meter per second? 12 meter per second, good? What happened? They stick together. Okay, let's say this is before, yes? After what happened? They stick together, yes? Good? And then they all move to the right direction, okay? All move to one direction. Okay, again, I use this momentum before, momentum after. What is the momentum of the small one? 0 plus. What is the momentum of this? Mass time velocity, yes? What is the mass? 3m. What is the velocity? Cool. Good. I am done. Momentum before should be equal momentum after. So what is the momentum after? What is the new mass? They stick together, yes? 3m plus m is going to be 4m multiplied by the entire velocity, okay? Because they are moving together. The mass of the momentum of the entire system is a new object, which is 4m, and they are all moving to the right, okay? Time v. Good? So what happened here, what I do, okay, 3m times 12 is going to be how much? 36m, yes? Equal 4m times v is going to be 4m v. Good? Okay, so what I do, m and m cancel each other. If I want to calculate v, okay, what I do? I divide by 4, divide by 4. Good? 4 and 4 cancel each other. V is going to be 36 divided by 4 is going to be 9 meter per second. What is the right answer? None of the above. Okay. Again, we use the conservation of momentum, okay, during the collision. When you have a collision, you are supposed to use this formula. Momentum before, momentum of the entire system before should be equal momentum of the entire system after. Okay, so calculate the momentum before, put it equal momentum after, and then find the unknown value. Any question? Okay, good. If there is no question, we can move on to question number 10. Okay, let me just erase these. Okay, question number 10. If you push an object twice as far while applying the same force, okay, you do, okay, it's talking about the work. Okay, what is the work formula? The work formula is this, yes? The work is force multiplied by distance, good? What is telling? If you push an object twice as far, if you were pushing this object, yes, with this force and is moving d, if you want to push the same object, yes, good, to move 2d, what you need to do? What was the force here, work here? F times d. What would be the work here? It should be F, yes, time 2d. Good. So the work should be double. Make sense? Because the work is directly related to the distance. If you're doubling the distance, you need to double the work. As long as you are keeping the force constant. Yes? What is the right answer here then?
Twice.
Twice as much. Okay. Question number 10. 100 joule of work in 50 seconds. This is work, just right. Work is 100 joule, yes. How many seconds? T is 50 seconds. What is what? Power. Go to the formula. Where is the power? Power is work over time. Okay, I have work, I have time. Power is gonna be 100 joule divided by how many seconds? 50 seconds. 100 divided by 50 is gonna be 2 joule per second. What is the other unit of the joule per second? Watt. Okay, joule per second or watt. So the right answer will be 2 watt. Okay, number 12. When bullets are fired from an airplane in the forward direction, the momentum of the airplane will be, what do you think? Unchanged, increase, decrease. When, again, the collision problem. Yes, okay. The momentum of when the bullets are fired from the airplane. Let's say there was an airplane here. Okay, this is the airplane. There was a bullet. Yes, here. Good. When is when it's not fired, they all moving together. Yes, okay. So they are moving together. They have the same momentum. But when it's fired, the momentum of airplane, okay, the bullet goes a little forward, yes, and then airplane will be a little backward, okay. So it means that if we want to keep momentum equal, yes, momentum before, momentum after the bullet will have a momentum. So what happened? So because the momentum is conserved, yes, momentum before and momentum before firing, momentum after firing should be equal. If we want to keep this constant, okay, the momentum of the airplane should decrease because it gives some of its momentum, okay, a portion of its momentum to the bullet. Good. So what is the right answer here then? Decrease. Makes sense, okay, because we are trying to keep the entire momentum constant. Momentum before should be momentum after. Okay? So, because the bullet is fired, okay, so because the bullet is fired, and then that's why the momentum of the is decreased. So, question number 13. After rolling halfway down an incline, marbles kinetic energy is. So let's say we have an incline, yes. The marble was on the top, yes. Now is on the middle, yes, halfway. What is the energy on the top?
I forget which one's on top, but it's
This one on the top. It's not rolling. Okay.
Yeah.
What is the energy on the top?
0.
No, not zero.
That's no,
We have a potential energy, yes?
right.
Okay. So because the object is above the ground, yes? Potential energy. This is a potential energy. mgh. You are h meter above, yes? Your energy is mgh. Okay? But when it's rolling halfway down, okay, what is the height? Height become half, yes? This is going to be mgh over 2. Okay. So what happened to the energy then? The rest?
That was the intrinsic energy.
Kinetic energy. Okay. The other half will be kinetic energy. Yes? Good. So here we will have kinetic energy and potential energy. Good. But the potential energy is half of the potential energy or the entire energy on the top. So which one is the right answer then?
The same. That's it.
Yes. Kinetic energy, okay, will become equal potential energy because what is the potential energy here? Half of the whole energy. Energy is conserved. Energy on the top is mgh. Energy here should be mgh. But half of it goes to potential energy. The other half will go to the kinetic energy, yes? Because when we add these two, it's going to be the total energy, the energy on the top. So energy is conserved. Energy on the top is the potential energy. Energy in the middle is the kinetic energy plus potential energy. Because it's halfway down, okay, the potential energy is half. The other half will go to the kinetic energy. That's why kinetic energy and potential energy are same. Question number 14. A ball rolling down an incline has its minimum speed halfway down the incline, okay, at the end of the incline, near the top of the incline, yes. Its minimum speed, yes, okay, it makes sense. It goes until about to stop, yes. When it's about to stop, it means that it does have its minimum kinetic energy but maximum potential energy. Good. But again, energy is conserved. Okay, so what is the right answer then? When it has minimum speed, when it's on near about the top, yes? Okay, because again, it does have maximum kinetic energy, good. And when it's about to top, okay, it's gonna be almost potential energy, okay? So it turned to the potential energy. That's why here it will have a very small portion. If it's a stop, it just will be potential energy. When it's about to stop, it means that a little kinetic energy, but most potential energy. So number 15, 2 kilogram mass held 4 meter above the ground. So we have 2 kilogram mass. How many meter above the ground? 4 meter. Good. What is the approximate potential energy? What is the potential energy? mgh. Good. What is the m? 2. What is the g? 10, yes. What is the h? 4. So what is the potential energy then? 80 joule, yes. 80 joule is the right answer. Question number 16. A car moves 4 times as fast as another identical. Okay. Let's say, you know what it's telling? It's telling that we have car, yes, M. One is V, yes. but the other one is the exactly the same car. Yes, identical car, the same car. But what is the velocity? 4 times bigger. Okay. Compared to the slower car, faster car has 4 times kinetic energy, 8 times kinetic energy, 16 times kinetic energy, 12 times kinetic energy. What is the kinetic energy formula? Kinetic energy formula is 1 over 2 mass velocity squared. You see that when velocity, kinetic energy, how it's changing with the velocity is changing velocity squared. It means that if you double the velocity, kinetic energy will be 4 times, yes? If you 4 times the velocity, the kinetic energy is going to be 16. If you increase the velocity 5 times bigger, okay, the kinetic energy is going to be how many times bigger? 25, yes. But here is 4 times, yes? Which one is the right answer then? 16 is the right answer. Okay. A car moving at 50 kilometer per hour. Okay, we have a car is moving with 50 kilometer per hour. Skid 20 meter with locked brake. Okay, when you push the brake, it takes 20 meter, okay, to completely stop. Yes, we call this a stopping distance. How far the car skid if the brake, yes, become the velocity become what? 3 times bigger, yes, 150 kilometer per hour. You have done experiment, okay, stopping distance experiment, yes, okay, in the at home. The stopping distance is directly related to the velocity score. Like the kinetic energy, which is directly related to velocity score, is stopping distance here directly related to the velocity score. How many times the velocity has begun?
3 times.
3 times. So it means that the stopping distance should be 9 times bigger, yes? When it was 50, it was 20. Now it is 150 is 9 times bigger than 20. It's going to be 9 times 20 is going to be 118. So again, stopping distance is directly related to the velocity squared. If the velocity double, the stopping distance will be quadruple. If the velocity triple, the stopping distance would be 9 times bigger. Yes, okay. So when it was 50, it is 20. 3 times bigger, it means it's going to be 9 times bigger. 9 times 20 is going to be 180 meter. Okay, a jack system will increase the potential energy of a heavy load by 1000 joule with a work input of 2000 joule. Yes? Okay. What is the efficiency? Where is the formula of the efficiency? Here, yes? Efficiency in percentage. Okay, which one we are supposed to use? Because there is a percentage here, yes? We are supposed to use efficiency in percentage. Useful energy divided by total energy multiplied by 100%. Yes? So your input was 2000, yes? Your total energy was 2000. What is your useful energy? How much is used? 1000. Multiply by 100%, yes? What is the efficiency of this?
50.
50%. Yes, 1000 divided by 2000 is going to be 0.5. 0.5 times 100 is going to be 50%. Okay. Let's move on to the question number 19. How many joules of energy are in 1 kilowatt hour? Okay, 1 kilowatt, yes, hour. I just write it down. Okay, 1 kilowatt hour is telling how much energy. Energy is joule, yes? How much joule? We know that kilowatt, okay, because this is a watt. Watt, we already know that it is joule per second. Good. So we try to just do the unit conversion a little bit. Okay, so this is 1 kilowatt. Okay, I just write down 1 kilowatt hour. Okay, I want to get rid of the kilo. Yes, 1 kilo is 1,000. Yes, of any unit. 1 kilogram, 1 kilowatt, 1 kilo. I whatever. So I write 1 kilo on the bottom. Yes, and 1,000 on the top. Good. So what happened here? These kilo and kilo cancel each other. I just have now, what is the new thing? New number is going to be 1,000, yes? Watt, good, hour, okay? I'll do the second unit conversion, okay? What is joule per second? I write here joule per second. Okay, let me just write it down, 1,000 joule per second, but multiply by hour, yes? I need to get rid of the hour. Okay. Hour is how many seconds?
Uh,
3,600.
yeah.
Yes. Okay. So I just write it down like this. Okay. Instead of hour here, I write 1 hour is 60 minutes. Yes. Okay. And then 60 minutes is, each minute is 60 seconds. Yes. Okay. Instead, let me just write it down like this. Okay. I just instead of hour, I just write, okay, let's say 1 hour, yes, is 60 minutes, yes. Each minute is how many seconds? 60 seconds. Good. So 1 hour is going to be 60 times 60. Yes, it's going to be 3,600 seconds. Good. So I just write, instead of hour, I write 3,600 seconds. Okay, what happened here? Second and second cancel each other. What is left? What is left?
Oh, Jules, sorry.
Joule. Okay. So let me just write it down. It's gonna be three, 6. How many zero? 1, 2, 3, 5. Yes. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This. Okay. So I think I am missing 1,000 joule per second. Okay. Kilowatt. Okay. 3,600. Oh, this is 3,600. Yeah. Yes, okay. I missed 1 0. Yes, good. No, it is correct.
No, that was correct.
Yeah, it was correct. Okay, so how many zero I have? 5 zeros. Yes, 1, 2, 3, 4, 5. This is 3 and then 3. Okay, so it's gonna be 3.6 million joule. Yes, or 3,600,000 joule, or 3.6 million joule. Okay, what is the right answer? 3.6. So question number 20. When a rifle is fired, it recoils as the bullet is set in motion. The rifle, yes, and the bullet ideally acquire equal amount of kinetic energy. No, yes, because the velocity of the bullet, okay, is bigger than the velocity of the rifle. Yes, okay, in the reality, okay, so but opposite amount of momentum. Yes, okay. So they will have the momentum of the bullet and the momentum of the rifle, okay, will be equal but opposite direction. Because before firing, the momentum of both was zero, yes? Momentum before should be equal momentum after. Conservation of momentum. That's why they will have after firing, okay, they will have same momentum but in the opposite direction. So question number 21. A feather and a coin dropped in a vacuum fall with equal, again, we already discussed, okay, because force will be different, yes? M times G, because G is the same, but it doesn't mean that the mass is, the weight is same, yes? The weight of the coin is going to be bigger than weight of feather, yes? Kinetic energy will be same or different? Different, okay. Again, the velocity will be same for both, okay, but the kinetic energy is 1 over 2 mass velocity squared, yes?
Right.
The one with bigger mass will have the bigger kinetic energy. Momentum, again, the same thing. Mass times velocity, yes? The velocity, again, is going to be same, okay, so, but the mass will be different. Because the mass is different, okay, so the momentum will be different. The only thing which is same is the acceleration, okay. 22. A car has a head-on collision with another car that was approaching with the same magnitude of the momentum. A third car driving with the same speed as the first car ran into an enormously massive wall. Which of the four objects will which of the four objects will experience the greatest impulse? The approaching car, the third car, the second car, the wall, or all will receive the same impulse? That's a good question.
I think the third car.
Hmm?
I think the third car.
Why third car?
Going to hit a wall or it stops almost immediately.
Okay. You know, what is the momentum of all cars? Momentum of the all cars is the mass time velocity, yes? It's telling that they have the same momentum before collision, all of them. Good? But when it's collide, all of them stop, yes? Okay. Changes impulse is, yes? Changes of momentum. Good?
Yeah. You tried to shrink us. He thought you were student.
Okay. Momentum final minus momentum initial. Good. What is the momentum final? They all stop. Yes? Zero. What is the momentum before? They were all same. So what is the same? Impulse of the all is going to be same, yes? Okay, because impulse is the final momentum minus initial momentum. Initial momentum of all of them are same. And the final momentum of all of them are same because they all stop, yes? So the changes of momentum for all is going to be the same because the changes of momentum is same, so it means that the impulse is same. Make sense? So all receive the same impulse. 23. Two 5,000 kilogram passenger cars roll without friction. One at 1 meter per second, the other one at 2 meter per second, toward one another. On a level track, they collide, they couple, and they all move away with a combined momentum. Okay. What we are supposed to calculate? The combined momentum, yes? Okay. So what is the momentum of the first one? 1 meter per second, yes? The other one, it is 2 meter per second, but opposite direction. Good. Let's say this one, okay, 5,000 is going 2 meter per second to the right, yes? Another 5,000, yes, going 1 meter per second to the left. What is the momentum of the first one? 5,000 times 2 meter?
10,000.
10,000. Positive or negative?
This one.
Positive. Okay, right is always positive. Plus, what is the momentum of the second one?
It's 5,000.
But negative. Okay, so negative 5,000. Yes? Good. Kilogram meter per second. So what is the total momentum?
5,000.
No,
Bro.
10,000. Oh, yeah. 10,000 minus 5,000.
Wait.
Oh, okay, so it's gonna be 5,000. Yes? So what is the combined momentum?
5,000.
If several balls, okay, question number 24. If several balls are thrown straight up with varying initial velocity, the quantity that will have the same value for each trial is the ball's maximum height, travel of the time of travel, acceleration. Okay, again, we just have these problems two time, yes? This is the third time, okay, we are having the same problem. What is the same? Always, it doesn't matter. You drop the ball, okay. You throw the ball, okay.
Well,
Same size,
yeah.
different size, okay. So
Acceleration.
acceleration. According to Newton, the greater the mass of the interacting object, the greater the gravitational force between them. Less gravitational force between them, greater the force between them by the square of the mass.
Greater the gravitational force.
There you go. The mass bigger, the gravitational force bigger, yes? Question number 26. If your mass, the mass of Earth, and the mass of everything in the solar system were twice as much as it is now, yet everything stayed the same, okay, your weight on the Earth would
Like quadruple.
if your mass, the mass of, and the mass of everything were twice as much as it is now, and everything is the same, the size, okay, what would be your weight?
Double, isn't it? It's
Your weight on Earth.
double, isn't it? Bro. It's the ones compared.
What is the force of gravity? Okay, you know the formula, you see that here? F is Gm1 m2 divided by distance squared, yes? How we calculate your weight? Okay. How your weight is calculated? By using this formula, yes? Let's say this is Earth, yes? Earth, and this is you on the Earth. I write the force of gravity between you and Earth, yes? It's gonna be F equal G mass of you, yes? mass of Earth divided by, what is the distance? Distance between you and the Earth is going to be distance from you to the center of Earth, yes? Which is going to be the radius of Earth squared, good? So, and then this become GMRE squared time your mass, good? This is the G, 10 meter per second squared, okay? Okay? Okay. You see here, your mass is doubled, the mass of Earth is doubled. Okay, what happened to the force of gravity? This is become 2 time m, yes? This become 2 time mass of Earth, or mass of everything on the Earth. 2 time 2,
Quadruple.
there you go. Because not only your mass is changing, yes, okay, the force of gravity, okay, the mass of the Earth is changing as well, yes, okay, your mass is doubled, the mass of the Earth is doubled, okay. Time, mass, time, another mass is going to be the force of gravity. The force of gravity is exactly your weight. The weight of the Earth is doubled, and the weight of you is doubled as well, okay? And then the weight of the entire thing is going to be quadruple. Good? A weight watcher who normally weighs 400 Newton stand on the top of a very tall ladder. So she is 1 Earth radius above the Earth. Yes, okay, see? I said the force of gravity was G, mass of U, mass of Earth, yes, divided by radius of Earth. Good? But right now, you are not exactly on the Earth, yes? You are, this was the distance radius, yes? You are high above the Earth, okay? But how much RE, yes? Another radius, yes? You are above the Earth, yes? So what happened to this distance? You remember the distance is squared, yes? This is the distance squared, good? The distance first time was RE, good? What is the distance here now? 2 time of the radius of the Earth, good? So force is inversely related to the distance squared. Okay, if your weight was 400, your distance is doubled, your weight is going to be 1/4, yes? Because the weight is inversely related to the distance squared. You remember when you were doubling the velocity, the kinetic energy would quadruple? Here, because the force is inversely related to the distance squared, yes, inversely. You see, the distance increase, yes, the force of gravity decrease. Now this distance become double, the force of gravity or the weight become 1/4. If the distance become 3 times, the force of gravity become 1/9, yes? If the distance is 4 times, yes, okay, the force of gravity become 1/16. Make sense? Okay, so because the weight was 400, now you go, another radius above the ground, okay, so your distance is double, your weight will be 1/4. Okay, what is the right answer then? 100. Number 28. The planet Jupiter is about 300 times as massive as Earth. Good. Yet on its surface, you would weight only about 3 times as much. Let's say this is Jupiter, yes? This is Earth, yes? The Jupiter, how many times bigger? 300 times, yes? When you are on the Jupiter, when you are on the Earth, and it's telling that your weight is 3 times as much. What is your force of gravity? I'm using this, okay? This is going to be a force of gravity, good? And it's telling that when you are on the Jupiter, okay, mass of you, yes? Mass of Jupiter, yes? Divided by, okay, I put the G here, yes? And the distance between the Jupiter center to you, okay, is going to be the radius of the Jupiter, yes? Square. And what is this force of gravity? Again, use the same formula. Good. G, mass of you, yes. Mass of Earth, good. Divided by, again, the distance between you to the center of Earth is going to be the radius of Earth squared. Good. But what is telling? Is telling that you weight only 3 times as much as when you are on the Earth. It means that this is equal 3 times of this. Good? I just converted to the mathematical equation. Okay, so 3 times as much as when you are on Earth. Your weight on Jupiter is 3 times your weight on the Earth. Good? Okay, so I just try to simplify. You remember it was telling that the mass of Jupiter, yes, mass of Jupiter, how many times mass of Earth? 300 times of mass of Earth. Good. Here, instead of mass of Jupiter, yes, I write how many times? 300 mass of Earth. Good. So try to simplify this. Okay, so mass of Earth cancel each other. Mass of you and mass of you cancel each other. These G and G cancel each other. Yes. Okay. What is left? 300. Yes. Divided by radius of the Jupiter. Yes. Squared equal nothing left. Yes. Okay. Just 3. Good. Radius of Earth is squared. Good. Okay. So which one do you think is Jupiter radius is 10 times radius of Earth? Your mass is 100 times less. Jupiter is significantly farther from the sun. You are 100 times more weight than, okay. It's not talking about the weight, okay. The only answer that is talking about the radius, okay, is which one? You don't need to just keep calculating this. Yes, okay. The only thing that is talking about the, radius, this is the radius. This is talking about what? Mass. No, I don't see any relationship about the mass. This is talking about, Jupiter is significantly far from. I don't know. Okay, so it does not related to the sun. Okay, do you see anything related to the sun here? No, it's not the answer. You are 100 times more weightless than. Okay, no, he's not talking about the weight. Yes, okay, so it's not the answer. Okay, what is the right answer? Radius. Okay, so again, but you can use this to calculate that. Yes, because 3 and 300 is going to be 100. Yes, and then you just cross multiply. It's going to be the radius of the Jupiter is going to be 100 times of the radius of the Earth squared. Good. Take the square root both. Yes. So radius of the Jupiter is going to be square root of 100 is going to be 10. 10 of radius of the Earth.
There you go.
There you go. I just wanted to show you that, you don't need to solve this problem. I just did solve it for you. Okay. But again, the only one that is talking about the radius is the first one. Okay. So, okay. 29. Okay. Number 29. Okay. Passenger in a high-flying jumbo jet feel their normal weight in fly, while passengers in the orbiting space, okay, shuttle do not. This is because passengers in the space shuttle are without support forces, okay, which makes sense. Yes, okay. So beyond the main pull of the Earth's gravity, about the Earth's atmosphere, okay, all of this, okay. So yeah, the right answer is without the support force. Okay. Number 30, a supplier wants to make a profit by buying metal by weight at one altitude and selling it at the same price per pound at another altitude. Okay. So you buy by weight, okay, in one altitude, okay, you sell by not weight, by mass, okay. Okay, in another altitude, okay. Which one is better? Disregard altitude because it's make no difference. No, mass and weight will be different. Your mass is always same mass, but your weight can be different. Let's say your weight on Earth is gonna be different than your weight on a Jupiter. We just mentioned that. Yes, okay. So good, okay. Because your mass is, let's say, 50 kilogram. You are 50 kilogram on the Earth, you are 50 kilogram on the Jupiter. But your weight is different because your weight is mass times gravitational acceleration. Your gravitational acceleration on the Earth is 10, on the Jupiter is probably more than 10 or less than 10, okay? We can calculate that. So now, what do you think? Okay, so when you go above, okay, your weight will increase or decrease?
Probably it'll increase.
No, because we just said that, okay?
Oh, no,
The
no.
weight, okay,
Okay.
inverse related to the
Right,
distance
right.
squared. If you go high above the Earth, okay, your weight decrease.
Decrease.
Yes, okay, the force of gravity decrease. Good. So what does it mean? If you wanna make a profit, so if you want to buy by weight, you go in the higher altitude or lower altitude. Higher altitude is going to be less price. Yes, okay, because the weight decrease. And then if you sell it, okay, you will come down to the ground, okay, to sell it. Okay, so what is the right answer then? Buy at high, yes?
Sell it low.
Yes.
Right.
There you go. Again, all of them is because of this force of gravity. Okay, so a rock is thrown upward at 50 degrees with respect to the horizontal. As it rises, its horizontal. Okay, so we are talking about the projectile. Okay, projectile is a motion, is a two-dimensional motion. The horizontal. Okay, so again, when the ball is in the air, let's say this ball goes, reach on the top. Yes, come back to the ground. Good. The only when there is no air resistance, the only force which is exerted is the force of gravity. Yes. Do you see any force in the horizontal direction? Because there is no force in horizontal direction, okay? Net force in horizontal direction is zero. When the net force is zero, it means that the acceleration is zero. When the acceleration is zero, it means that there are two situations. The object doesn't move. If it's move with the constant velocity. Because the object is moving, it move with the constant velocity to the right, yes? Okay, through the horizontal. But vertical, we already know. The only force which is exerted is the force of gravity. Okay. Because there is a force, there is acceleration. Because there is acceleration, the velocity when goes up, decrease, when it goes down, increase. Yes? So what happened to the horizontal velocity? Stay same. What happened to the vertical velocity? Slowing down, speeding up. Yes? The velocity change and it's changing with the force of gravity. So if I want to answer this, okay, so what happened? Horizontal component is stay same, yes? Remain unchanged. A rolling ball, roll a bowling edge of a table. As it falls, its horizontal component of the velocity again remain constant. Yes. An Earth satellite is simply a projectile. Yeah, projectile. Okay, is a free fall. So, which one is the right answer? Okay, so approaching the Earth from outer space, floating motionless in a space near the Earth, freely falling around the Earth.
Freely falling.
Yes, freely falling around the Earth. Okay. Satellite are simply Satellites are simply free falling in such way that they continually fall around the Earth. Oh, sorry, this is a feedback for my bad. Question number 34. A gun with a muzzle velocity of 100 meters per second is fired horizontally from a tower, yes? Neglecting air resistance, how far down range will the table be 1 second later? Okay, that's a good question. So it's telling that, is from a tower. Let's say this is a tower, yes? Good. And it is 100 meter per second, good, horizontally, and is how far reach down towards the ground, yes? And it's telling how far down range will the bullet go 1 second late. Let's say how far this will be, yes? How many seconds later? 1 second later. We need to go back to these equations. Okay. You remember we said that if we want to calculate this, because horizontal velocity is constant, yes? Which formula I can use to calculate the, what is the formula, constant velocity formula? Distance is equal, distance is equal, yes? Horizontal velocity, yes? I call this horizontal velocity. Horizontal velocity multiplied by time. Do I have velocity? Yes. Do I have time? No.
No.
Yes. It takes how many seconds?
1 second.
1 second later. Okay, one. Good. Okay, it doesn't say okay how far it goes. Okay, so okay, because we will have a problem. Okay, that will. What is the distance? 100 meter. If it was telling 2 second later, 100 times 2,
200.
200. Yes. If it was telling 3 second later,
300.
300. Good. Okay, so that's why we use the constant velocity distance. Okay. Because horizontal velocity multiplied by time is going to be the distance that it shows how far it's traveled. Good? So it's going to be 100 meters. 35. What prevents satellites such as a space shuttle from falling? The absence of air drag, gravity, nothing.
We just had this question. It's nothing.
Yes, nothing. There you go. Without air resistance, a projectile fire horizontally at 8 kilometers per second from the top of the mountain. Okay, first curve that match the Earth's curvature, accelerate downward as at g as it's move horizontally. Okay, return later to its starting position and repeat its falling behavior. All of the above, all of these or none of these? All of this, okay. Because it's going through the curve, yes, that matches the Earth's curvature.
Mhm.
And it's accelerating downward, which is the gravitational acceleration, and it's returned later to its starting point. Okay, so it's not hitting the ground. Okay, it's come back to exactly to the starting point. Okay,
I gotcha. That makes sense. Huh? Okay.
good.
Yep.
37. A ball player wished to determine pitching speed by throwing a ball horizontally from an elevation. Okay, let's say this is a 5-meter elevation. Yes. And it's telling that it's throwing the ball horizontally. It means that it's throwing the ball horizontally. Good? Okay. The player sees the ball land how many meter down? It's going to be 20 meter down. It's gonna be here, yes? But this is the velocity. What is this speed? Okay. You remember I said that distance is equal horizontal velocity multiplied by time. Distance is horizontal velocity. I call this V horizontal. Horizontal velocity multiplied by traveling time. Good? Okay. So, do I have distance? Yes. Do I have velocity? No. Do I have time? No. Okay. How can I find the time? There you go. You remember in projectile motion, we have two-dimensional motion. One, horizontal is motion with the constant velocity. This is the formula that I wrote for constant velocity. What is the formula for constant acceleration? There you go. This is the distance, this is the distance horizontal. I write d vertical, which is 1 over 2 gt squared. What is the d vertical? 5, yes? Make sense? Okay, let me change the color. D vertical, this is a vertical. It does make sense, this 11 means horizontal, this is vertical. So this is going to be D vertical then in projectile motion. 1 over 2 gt squared. What is the D horizontal? Okay, D horizontal is going to be V times T. Good? We already have D horizontal. Okay. And we want to see what is the V horizontal. Good? But we need to find the time. We don't have time, but we go back to D vertical, which we already have. We just write 5, 1 over 2. What is this? 10. Good. Okay. Uh, T squared. Good. Okay. Try to simplify this. Let me just use this guy. 10 divided by 2, 5. Oh my God, it is too bright. 5, yes? 5 and 5 cancel each other. What is left is going to be t squared 1. Okay, t is going to be 1 second. Good. So it takes 1 second. This ball goes down. Yes. Okay. I calculate this. Yes. So d horizontal is 20. V horizontal multiplied by time. What was the time? 1 second. Yes. What is the V horizontal then?
20.
There you go. V horizontal should be 20 meter per second. So again, we have d vertical and d horizontal. D vertical is going to be the d with the acceleration stuff, yes? D horizontal is with the constant velocity. Okay, you need to combine these two, okay, to get to the final answer. Any question? Those who are at home, okay, so I didn't see anything on the chat since we started. Okay, I assume that everything is good. If everything is good, okay, please put yes in the chat. There you go. So question number 30. Oh, 8. Okay, so 38. Okay, what 30? A box with a mass of 1 kilogram, okay, start at the top of the incline with an initial height of 140 meter. Okay, the initial height is 140 meter. Okay, so calculate the box potential energy in Joule. Okay, what is the potential energy? Again, potential energy is what? Mass GH, yes? Potential energy is mgh. What is the mass? 1 kilogram. What is the g? 10. What is the height? 140. Yes? How much will be? 1400. Yes? Your numbers might be different. Okay, so make sure that you are using your own numbers. Good? Okay, because mine in here is telling that the initial height is 140. My mass is 1 kilogram. Your mass might be different or your height will be different. Okay, so
I have the same one.
okay, perfect. If it is the same, okay, so the right answer is going to be okay. So what is the next one? Okay, it's telling that 4 kilogram. Now it's 4 kilogram. Okay, with the height of 100 meter, slide down and calculate the kinetic energy of the box. Okay, when it is 80 meter. Okay, kinetic energy here. Good. So let me just calculate the energy, because what is the kinetic energy on the top? 0. What is the potential energy on the top? mgh. What is the m? 4 time 10, yes, time, what is the h? 100. Okay, the initial height is 100. So what is the energy on the top then? E total. It's going to be PE plus KE. So which is going to be 4,000, yes? Plus 0 is going to be 4,000 joule. So again, when kinetic energy is 4,000 on the top, when the total energy is 4,000, the total energy is 4,000 everywhere, yes? When it's here is 4,000, yes? When it's here is 4,000. So how we can calculate the kinetic energy here? Because here, when the ball is sliding down, it does have kinetic energy plus potential energy. But the potential energy is different than when it is in 100 meter above. Okay, so how can I calculate the potential energy when 80 meter above the ground? It's going to be mass. What is the mass? 4, yes. What is the G? 10. What is the height? 80. So calculate the potential energy. It's going to be 3,200 joule. Okay, so this become potential energy is going to be 3,200 joule. So 4,000 equal kinetic energy plus 3,200 joule. What is the kinetic energy here then? What number should be added to 3,200 to become 4?
800.
800. Good. Make sense? So kinetic, because the total energy should be conserved. Okay. The total energy on the top is 4,000. When it's on the 80 meter, it should be 4,000. We need to use a 80 meter to calculate the potential energy, which we use, and to calculate the potential energy, which is 3,200. How much energy is lost through the kinetic energy? Okay, so 800. Yes. Okay, projectile. A ball is a ball of mass is 1 kilogram with a vertical velocity of, okay, vertical velocity is 70. Again, your number might be different. Okay, and horizontal velocity is 30. Good. Calculate the velocity of, calculate the vertical velocity. Good. Vertical velocity 3 seconds later. You remember the vertical velocity is slowing down and then speeding up. Go up, slow down, go down, speeding up. But horizontal velocity is always constant. You remember last time we said that every second the velocity slow down 10 meter per second? It was 70. 1 second later it's become 1 second later it's become another second become, okay, so 3 seconds later is, what is the velocity? 40 meter per second. Yes, it's 70 here. 3 seconds, let's say 3 seconds later here. Yes, what is the velocity? 4 meter per second. Why? Because for each second the velocity decrease 10 meter per second. Make sense? So how long does it take to go up? How many seconds it takes to go up?
For 70?
Yeah, for 7, yes. 7 seconds, yeah?
7 seconds. 7 or up.
7 seconds it takes to reach to the highest. Okay. Here, a ball with a mass of 2 kilograms thrown with a vertical velocity of, this is the vertical velocity of 80. Okay, what is the horizontal velocity? 40. Calculate the ball horizontal velocity. Okay, 8 seconds later. Horizontal velocity doesn't change. 40 meter per second forever. Yes? Good? It's going to be 40. Okay. So a ball with a mass of 2 kilograms thrown with a vertical velocity of, again, this is a vertical velocity, 60 meter per second. What is the horizontal velocity? 30 meter per second. Good. Instead, calculate how high above its original. Okay. is asking us to find the vertical distance, yes? You see, what was the vertical distance formula? I just told you. The vertical distance, yes, it is 1 over 2 gt squared. Okay? Okay. What I need, I do have g, yes, it's 10. What is the time? How long does it take to reach on the top? What is the vertical velocity?
60,
How long does it take to get to this top?
6 seconds.
There you go, 6 seconds. And I just need to plug this 6 second here, yes? It's gonna be 1 over 2, 10, 6, power of 2, yes? Okay, it's gonna be 1800 meter, okay? Makes sense what is happening exactly? Okay, so I need to find the vertical distance. Ben is telling how high it goes. I need to find the vertical distance. Vertical distance is 1 over 2 gt squared. Good? Okay, I have vertical velocity. Vertical velocity is 60 meter per second. And these help me to find the time, how high, how long it takes to go to the top. Because in my formula, I need time, yes? If I find the time, I can calculate the vertical distance. I find the time, okay, which is takes 6 seconds. I plug this 6 second into the formula, and then I calculate there. Any question here? Those who are at home, okay. If you have any question, please let me know, okay? I can explain more than one time if it doesn't make sense. If it makes sense, okay, so we can move to the next problem. Okay, sounds good. So, okay, a ball with a mass of 1 kilogram is thrown with the initial velocity of v, and okay, it's telling that vertical is 80 meter per second. Again, in my problem, okay, horizontal is 50 meter per second. Calculate the distance it has. There you go. Okay, very, very good question. It's telling that calculate the distance. What distance? Vertical or horizontal? Horizontal, yes? Okay, what is the horizontal formula? Let me just write it down. Horizontal distance, yes, is equal velocity multiplied by time. What is this time? How long does it take the ball go up, yes, and then go down? This is that time. Good. But what is the horizontal velocity? 50. 50 multiplied. What is the time?
Uh, 16.
Perfect. Why you say 16? It takes 8 seconds go up, yes? It takes another 8 seconds to go down. The total traveling time is going to be 16 seconds. So what is the horizontal distance then? 16-second time. 16 time 50 is, oh, sorry. 16 times 50 is going to be 800, yes? Again, make sure that you are using your own numbers, okay? Probably my numbers is different than your number. Good?
Yeah, ours is 90 and
Okay.
20.
So again, this, the traveling time is becoming important. If you are, firing from a tower, it's going to be just falling down, yes? When you are going from earth to earth, from ground to ground, yes? Okay, so it means that the time goes up, the time goes down. Okay, how we can calculate time? By having the vertical velocity. Vertical velocity help me to find the total traveling time because it's 80 meter per second. Every second the velocity decreases 10 meter per second. It takes 8 seconds to go up and then stop and then come back. Another 8 seconds to go. So the total traveling time is going to be 16. Okay, so we are done with this, okay? And I think, those handout problem is exactly like, these problem that we solve, okay? I think it is not necessary, okay, to work on those problems. So I'm gonna stop recording. If you have any question, we have a couple of minutes. If you have any question, please let me know. If you don't have any question, we can stop the session. Okay, I'm gonna stop recording for now. I hope you enjoyed the exam prep party. So please send me an email if you want to have access to the recorded session. Bye.